Here's an example where they give us tangent is a negative fraction and tell us the sine of theta is less than 0, and they want us to come up with all 5 of the other trig functions other than tangent, which they've already given us. So let me write this out in a way that looks more familiar. They're saying that the tangent of theta is negative 8 over 5. Can you read that okay? Negative 8 over 5. There might be a little more room there, but I guess not. So here, let me write it here. Tangent of theta is negative 8 over 5. Okay. So, and what's it saying here? The sine of theta is less than 0. How do we do this? This is a little tricky. So, when given one trig function and one other piece of info. So that's what's going on here. They've given us one trig function and one other piece of info. Step 1 is you've got to find the quadrant by what? So here's what I want to show you. Here's the way to find the correct quadrant. There's a nice little memory device to help, and it goes like this. All students take calculus. All students take calculus. Now, it's not really a true statement. Maybe it should be. I don't know. But I'm a math teacher. My opinion probably doesn't count. But anyway, notice I did these starting in the first quadrant and then just went second, third, fourth quadrant. Went in quadrant order. 1, 2, 3, 4. Just like the quadrants go. All students take calculus. Quadrants 1, 2, 3, 4. Right? That saying helps you determine the signs. What is it saying? It's saying all six trig functions are positive in the first quadrant. Remember the 6. Let me write out what would be best. Let me come down here and write out the definitions of the 6 again. So the sine of theta, remember, I'm going to use this definition, the opposite over the hypotenuse. It's also the y value on the unit circle. That's another way to say the same thing. We're not using the unit circle right now, so we'll go with this definition. Both are true. They're different ways of saying the same thing. Cosine of theta is the adjacent over the hypotenuse. Tangent of theta. And remember the other 4 trig functions are all just made out of sine and cosine. So tangent is sine over cosine, and then the other 3 are all reciprocals. They're upside down of the first 3. So cosecant is 1 over sine. It's upside down. Oops. And secant is upside down of cosine. And cotangent is upside down of tangent, so it's cosine over sine. So do you see how this is upside down, upside down, upside down, isn't it? Right? Sine over cosine, upside down, cosine over sine. Okay. So there's the 6 trig functions. Now why do we care about that? Well, here when I say all 6 are positive, I mean these 6. I mean sine, cosine, tangent, cosecant, secant, cotan. All 6, or 6 of them, right? All 6 of them are positive in the first quadrant. Now, next, S. Now, what do you think that S stands for? Well, of course it stands for sine. But notice sine always goes with cosecant, because cosecant is the same as sine, it's just upside down. So it's going to have the same sign. For example, if sine is positive, then cosecant's going to be positive because it's the same thing, it's just upside down. If sine is negative, then cosecant's going to be negative because it's the same thing, it's just upside down. That same truth goes for these 2 and these 2, right? If this one's positive, so is that one. If this one's negative, so is that one. If this one's positive, so is that one. This one's negative, so is that one, right? Because they are just the upside downs of each other. So they've got to have the same sign. So therefore, when it says up here that sine is positive, it also means cosecant is positive. And the other four are negative in that quadrant. That's what it's saying. When it's saying sine positive, we're understood to mean sine and his upside down, cosecant, are both positive, but the other four trig functions in that second quadrant, this is the second quadrant, first quadrant, are negative. Now that you get the pattern, I bet you can figure it out. What is this saying? It's tangent, isn't it? It's saying tangent's positive, and of course his upside down is going to always be the same as him, cotan. And the what? The other four are negative. So in the third quadrant, only tangent and cotangent are positive. The other four trig functions are negative. And then finally, in the fourth quadrant, you know C stands for cosine is positive. And his upside down, what's upside down of cosine? Secant. They're going to be the same sign always. So only cosine and secant are positive. The other four are negative in this, the fourth quadrant. So that's a really quick, handy way to know which trig functions are positive and which are negative in which quadrants. All students take calculus, just put them in the four quadrants, all students take calculus, and that tells you all are positive, sine and his upside down are positive, only tangent and his upside down are positive in the third, only the other four are negative, and cosine and his upside down, secant, are positive only. The other four are all negative. All right, so now we're ready to get down to business. So it says here that the sine is less than 0. That means that the sine is negative, right? Less than 0 means negative. And notice the tangent is negative also. So which quadrant, that's the question before us. We're trying to find the quadrant. Tangent's negative and sine is less than 0, which also means negative. They're telling us, hey, here's the hints. Tangent and sine are both negative, right? They gave me a negative number for tangent there, and they told me sine is less than 0, which means negative. So which quadrant am I in? Could I be in the first? Let's go through it. Could I be in the first quadrant? No, they're all positive. In the first, no way. Could I be in the second quadrant? No, sine is positive here, it says. And they told us sine is negative. No. Could we be in the third quadrant? No. Tangent's positive here, and they told me tangent's negative. Well, then we got to be in the fourth. Is that right? Yeah. Only cosine and secant are positive. The other four are negative, which would mean tangent and sine and whatever the other two are also. Yeah, we are in the fourth quadrant, aren't we? For sure. So you see how we concluded that? They gave us enough information. So these things mean fourth quadrant. So that's your first step. Find out what quadrant you're in. Okay, good. So we're in the fourth quadrant. Second step. Now we're going to draw our right triangle. So right triangle from the origin to the x-axis, always the x, not the y-axis. That's important to get the right angles in that quadrant. So let's go up and do that. So I'm going to come up here now, and I'm going to draw, starting from the origin, I'm going to draw and then go to the x-axis like that. Make a right triangle. It's very important I didn't go this way to the y-axis. That would get you the wrong answers. So there we go. So draw your triangle. That's in the fourth quadrant. You picturing it? This is first quadrant, second quadrant, third quadrant. This is the fourth quadrant. So I'm in the fourth quadrant, drawing my triangle there. Let me make this go up a little further and this go this way, right? I'm in the fourth quadrant. Okay, let's go back to it. So now, step number 3. Put theta at the origin. Put theta at the origin. And use SOHCAHTOA. What do I mean by SOHCAHTOA? These, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is sine over cosine, which is opposite over adjacent. So use those definitions for sine, cosine, and tangent. SOHCAHTOA. So how so? Well, they gave me tangent. Right here in the beginning, they gave me tangent. So what is tangent? What does it say tangent is? Opposite over adjacent. So that means opposite over adjacent. So the 8 is the opposite and the 5 is the adjacent, because tangent is opposite over adjacent. Now here's the trick though. One of those has got to be negative, because that's a negative tangent, but that negative is kind of in the middle front, so it could go with either one. Let's take a look at the diagram, and I know we'll be able to figure it out. So let's put theta at the origin, and let's be clear, this is the side that is opposite of theta, right? It's across from theta, and right there is the hypotenuse across from the right angle. So this is the hypotenuse, and this is the adjacent side, because it's touching theta. It's right next to theta. All right, so the opposite is 8. Let's just put in the numbers first. The opposite is 8, right here. Opposite is 8, and 5 is the adjacent. 5 is the adjacent. Now, which of those is positive and negative? Well, let's come back to that. Well, you can see, right? From here, this is the origin. You would go right and down to reach this point and make this triangle. This point here, this is positive 5 and negative 8, isn't it? See how it is? This must be the point over 5, down 8. Positive 5, negative 8, right? Just by the x, y. This is the x-axis. This is the y-axis. It's a coordinate system, and this is the origin right here. So this is right 5, down 8. So that's how we know the coordinates and which is positive, which is negative. All right, let's go on. Now step 4. Find the missing side by a squared plus b squared is c squared, the Pythagorean theorem. So use the Pythag now to find the missing side. I'm going to need to erase a little bit. Have some room here to do this. Take out the all student stuff. All right, so here we go. So a squared plus b squared is c squared. So which one's the c? The c has got to be the hypotenuse. So we'll say 5 squared plus negative 8 squared is c squared. C is always the hypotenuse because it's the longest side. So, right, the other two have to add up to equal it, squared. So 25 plus 64 is c squared. That's what? 89 is c squared. Root it. And so is that, I don't think that's a very nice number. No, it just comes out some ugly decimal. So I'm just going to leave it like that. It's just root 89. Just gonna leave it that way for now, and we'll just take it from there. So, okay, so we've got C. Let me bring that back over here. Root of 89. So we've got all three sides now. So now we've got the whole triangle, all three sides, and we're in position to answer all the questions. So here we go. So how do we do the sine of theta? Well, we know the definition of sine, opposite over hypotenuse. So sine, opposite over hypotenuse, opposite, hypotenuse, negative 8 over root 89. See that? Let me create some space here. So negative 8 over root 89. Just getting that from the triangle. Opposite, hypotenuse. So now we can't leave a root in the bottom, so we multiply top and bottom by root 89, and we get minus 8 root 89. The bottom is just plain 89. Because root 89, two of them together, make one plain 89, like that. So there we go. There's our first answer, minus 8 root 89 over plane 89. The next one, they want the cosine, which is adjacent over hypotenuse. Let's go grab the adjacent. So adjacent right here over hypotenuse right there. 5 over root 89. 5 over root 89. And again, we can't leave the root in the bottom, so multiply top and bottom by root 89, and we get 5 root 89 over plane 89. There we go. Now for the tangent. Now tangent we don't have to do. They already gave us tangent. I mean, that's minus 8/5. They're not asking us for tangent. They gave us that in the beginning. Now cosecant, which is 1 over sine. So I just take the answer for sine right here and I flip it. Now let me show you a trick to make this easier. I'm going to take the sine. Let me do it the hard way. Well, let me show you that if I take this guy and I flip it, I'm going to get 89 over minus 8 root 89. And then I've got that root in the bottom, and I'm going to have to deal with that and multiply top and bottom by root 89 and all that, blah, 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 blah. You know what would be easier than doing that, messing with all that? Is just go back here, the answer you first got before you multiplied top and bottom by root 89, and just flip that. Right? Just take this guy and flip him. That will be better. Minus root 89 over 8. Do you see what happened there? I just took this version and flipped that. That way I don't have to mess with the root on the bottom. You might say, well, yeah, is that right though? Yeah. When I multiplied top and bottom by root 89, this is just a fancy 1. I didn't change anything. I did the same thing top and bottom. So this answer and this answer are really the same. They just look different. You could flip either one. And it's way better to flip this one because that way you don't end up with a root on the bottom. You don't have to mess with it. You see that trick? So just do that. So boom, like that. And now next one for the secant, 1 over the cosine. Let's do the same trick. Just grab this one and flip it because it's upside down, right? These guys are just upside downs. So just grab that guy and what do you get? Root 89 over 5. So 5 there. There we go. And finally, cotangent. How are we going to do cotangent? Well, it's actually easy. They gave me tangent in the beginning, right? Tangent was the very first thing they gave me, minus 8/5. They told me that in the beginning. Cotan, you just flip it, right? Just grab that guy and flip it. These are the 3 functions on the right. Cosecant, secant, cotan are just the flips of the 3 on the left. So just grab it and flip it, minus 5 over 8. There it is, flipped in place. So we were able to find all the answers. Now, it's good to double check. Let me write, whoops, that's not very good writing. Right, step 5. I'm still writing badly. Let me try to switch the pen. There we go. All right. Double check. This is kind of important. A lot of people get messed up here. Double check all signs are correct by the all students take calculus sign check thing. You know what I mean? Which quadrant are we in? We verified up here we're in the 4th quadrant, right? Okay, look at the picture. We're in the 4th quadrant, 4th quadrant. What's true in the 4th quadrant? Right here. All students take calculus. Cosine is positive and secant is positive, and the other 4 had better be negative, right? That's if you're in the 4th quadrant, which we are, then cosine should be positive, secant should be positive, and the other 4 trig functions should be negative. Is that what we have? Cosine and secant positive, the other 4 negative? Let's see it. Cosine, yeah, he's positive, isn't he? And secant, yeah, he's positive. Are the other 4 negative? Negative, negative, negative. There's the negative. Yep, it's good, looking good. So that's a good double check on your sign. So there's the 5 steps for how we do that type of problem.